Welcome back to the course Engineering Chemistry. I am Dr. Harika Patnala, Associate Professor, Department of Chemistry, MLR Institute of Technology, Hyderabad. In this lecture, I am going to discuss about the water and its treatment, its introduction. Let us move to the introduction. What are the sources of water? In this lecture, we are going to discover the sources of water, how it is contaminated by the various components, and hardness of water and its units. Let us discuss the first topic is sources of water. So there are the various sources of water on the earth. One is surface water. It is any source of water body above the ground like lakes, rivers, ponds, streams, etc. Underground water. The groundwater sources are beneath the land surface like wells, springs, water springs. The third one is rainwater. It is the purest form of water and the main source of water in the tropical communities. So the rainwater, which is the purest form of all the waters. Seawater. Seawater contains number of salts like chlorides, carbonates, bicarbonates, sulfates of sodium, potassium, calcium and magnesium, etc. It is nothing but calcium carbonate, calcium bicarbonate, calcium sulfate, calcium chloride. Potassium sulfate, potassium chloride, potassium bicarbonate, potassium carbonates. Magnesium chloride, magnesium carbonate, magnesium sulfate and magnesium chlorides. All these are the various salts which are present in the seawater. All these are the sources: surface water, underground water, rainwater and the seawater. These are the waters which contains various contaminants. The types of impurities present in the water. There are the main types of physical impurities, chemical impurities, biological impurities. The natural water is usually contaminated by the different types of impurities. The first one is physical impurities. These are the suspended solids that are not completely soluble in water. Let us check that color. See, color is visible to a naked eye. In water is caused by the metallic substance like salts. So the color is because of salts present in the water. Turbidity is due to the colloidal particles, because of clay, slate and microorganisms. All these are also responsible for the color which are present in the water. So the color present in the water is because of salts and colloidal particles like clay, slate and microorganisms. And the second physical impurity is taste. It is a characteristic property which is present in the water is physically present in the water. Presence of dissolved minerals in the water produces taste. Nothing but salts. Bitter taste, one is bitter taste, can be due to the presence of iron, aluminum, manganese, sulfate. Iron, aluminum, manganese, sulfates and lime, these are responsible for the bitter taste. Soap taste is due to the presence of large amount of sodium bicarbonate which gives soap taste. So the main physical impurities are color and taste is because of the salts, clay and microorganisms which are present in the water. Next, chemical impurities. Again, the chemical impurities are classified into two types. One is inorganic and other is organic chemicals. Inorganic chemicals, we know that other than hydrocarbons such as metals, aluminum, calcium, magnesium, iron, zinc, copper, sodium, potassium. Anions like chlorides, sulfates, nitrates, bicarbonates, fluorides and nitrates. All these are the responsible for the chemical impurities, nothing but the salts which are present. All these comes under the inorganic. Example, aluminum nitrate, calcium sulfate, zinc nitrate, zinc sulfate, zinc chloride. All these are the chemical impurities, comes under inorganic chemical impurities. And the next one is organic chemicals. These organic chemicals which are released from the industries mainly dyes, paints, petroleum products, pesticides and the detergents, drug, textile materials. All these are the various impurities from the various industries are going to be released into the water bodies. mainly lakes and river. So, and the other one is the biological impurities. The third type of impurities present in the water is biological impurities. Biological impurities are algae and pathogenic bacteria and fungi, viruses, and pathogenic parasite worms. These are released because of the agriculture, from the agricultural and human waste, and some of the dead bodies of fishes and everything from the plants, humans, and animals which are released into the water bodies. All these comes under the biological impurities. And the fourth one is colloidal impurities. There are very finely divided dispersion of particles in the water. These particles are not visible to the naked eye, but these are also responsible for the hardness, nothing but it is a property of water. All these are the impurities which are present in the water are physical impurities, chemical impurities, biological impurities, and the colloidal impurities. Let us move to the next topic is hardness. Hardness is nothing but a characteristic property of water. It's a property of water. What is going to do? It prevents the lathering of soap. Which prevents the lathering of the soap due to the presence of certain salts like calcium and magnesium and other heavy metals present in it. What are those salts? Calcium bicarbonate, magnesium bicarbonate. Let us write calcium bicarbonate, CaHCO3 twice, magnesium bicarbonate, calcium chloride, magnesium chloride, calcium sulfate, and magnesium sulfate. All these salts which are present in the water which prevents the lathering of soap. Prevention of lathering of soap is nothing but hardness. It is a characteristic property of water. We know that soaps are some salts. Soaps are sodium and potassium salts of higher fatty acids. Oleic acid, palmitic acid, palmitic acid, stearic acid, C17H35COONA. Soaps are nothing but sodium and potassium salts. One of the examples is sodium stearate. This is the soap. When we react with water with soap, if water consists of these type of salts, which prevents the lathering of soap and which forms white PPT called scum. This indicates that water is full of hardness. Hard water does not give lather with soap. Hard water which does not give lather with soap because of these salts. While the soft water gives readily lather with soap, the soft water also contains the salts but very less amount. What is the range? The range is nothing but 0 to 50 ppm. We will discuss in degree of hardness. So, hard water does not give readily lather with soap. While the soft water gives readily with soap, the hard water is gives because of the lather is because of the various salts, hardness causing salts. All these are the hardness causing salts which are present in the water which prevents the lathering of soap. Causes of hardness. Let us check the reactions with soap. When soap comes in contact with the soft water, lather is produced immediately due to the stearic acid and gives the stearic acid. If you see this is a sodium stearate. C17H35COONA is a sodium stearate. This is the water which is having the calcium chloride which is present in the water. So, if it reacts with sodium stearate, nothing but soap, you will get the C17H35CO twice calcium. Nothing but calcium stearate which is insoluble scum. We are going to notice nothing but white scum, nothing but PPT. So, when soap come in contact with hard water, sodium stearate will react with dissolved calcium and magnesium salts and produces calcium stearate and magnesium stearate. See, let us see this soap with magnesium sulfate gives magnesium stearate and sodium sulfate. These are the byproducts. Sodium chloride is a byproduct and sodium sulfate is a byproduct, and the main products are insoluble scums, white PPT. If it is the hard water, it does not produce any insoluble scum. Only hard water produces insoluble scum. Degrees of hardness. Based upon the hardness, the amount of hardness present in the water is classified into various types: hard water, soft water, moderate hard water, and all these. Let us know what is the ppm and what is the range of hardness present in the different types of water. Degree of hardness. Different types of water having different degrees of hardness. The different types of water are commercially classified on the basis of degree of hardness as follows. Let us see this, the differentiation, hardness and the name of water. If water is having 0 to 17 milligrams per liter of hardness, nothing but the 1 liter of water contains 0 to 70 milligrams of any hardness causing salts, that water is called soft water. If 1 liter of water contains 70 to 150 milligrams of any hardness causing salts, that water comes under the moderate hard water. If 1 liter of water contains 150 to 300 milligrams of any hardness causing salts, as calcium bicarbonate, calcium chloride, magnesium sulfate, that water comes under the hard water. So the water which is having 300 milligrams of hardness causing salts per liter and above, it comes under very hard water which is not suitable for drinking. It completely comes under the bore water. So the water which is suitable up to is in India is 150 milligrams per liter. So we can have 0 to 70 milligrams per liter and 70 to 150 milligrams per liter. All these are the hardness causing salts which are present in the water is because of running water. The rivers are contaminated with running water, the rainwater which comes under from the higher plateaus. The ponds which are contaminated with many salts, nearby industries and biological impurities from the agricultural waste and everything. Let us move to the next topic, degrees of hardness continuation. So the total hardness of water is caused by mainly the 8 different dissolved salts. What are the salts responsible? Salts are calcium and magnesium salts. Those are calcium bicarbonate, calcium chloride, calcium sulfate, calcium nitrate and magnesium nitrate. All these are the 8 salts are responsible for the hardness. Hence the hardness of water is expressed in terms of calcium carbonate equivalent. Let us know the name of the salt and its molecular weight. See guys, which are helpful for the determination of hardness of water. These are the calculations which are required. For the calculation, we require the molecular weights of each and every salt. Calcium bicarbonate is 162, magnesium bicarbonate is 146, calcium chloride is 111 and magnesium chloride is 95 molecular weight. Calcium sulfate 136, magnesium sulfate is 120 and calcium carbonate is 100. Please note this point, the calcium carbonate molecular weight is 100, which is helpful for the weight calculations. We know that we are having various currencies. In India, we are having rupees. In US, they used to call as dollars. So, if you are having various currencies with you, if I ask you the total amount of currency you are having, you cannot say that I am having $3, 100 rupees in this way. You will convert every currency into rupees, because in terms of rupees you will explain that because in India we used to our currency in rupees, so we will convert everything into rupees, which is flexible to us and which is easy for the calculation. Similarly, whatever the salts which are present in the water, either calcium bicarbonate and magnesium bicarbonate or calcium chloride or magnesium chloride, every salt and its amount should be converted into in terms of CaCO3, which is expressed in terms of CaCO3 because it is easy for the calculation. Its molecular weight is just 100. It is easy for the multiplication and division. So that's why we are expressed everything in terms of calcium carbonate, hardness in terms of calcium carbonate. If the water is having 50 milligrams of calcium bicarbonate or 100 milligrams of magnesium bicarbonate, everything is converted in terms of calcium carbonate. It is expressed in terms of calcium carbonate because for the easy calculation and for the easy determination of total hardness present in the water. Let us move the topic called units of hardness. There are the various units. In various countries, let us consider that in India, weight is calculated in terms of grams and kilograms. In other countries, they will calculate in terms of pounds. In India, water is taken in the volume of anything, liquids are taken into the liters. In other countries, they will consider as gallons. Let us move to the units of hardness. First one is parts per million. It is the parts of calcium carbonate equivalent hardness per 10 to the power of 6 parts of water. We know the density of water is 1. Mass by volume is 1. So, 1 kg of water is equal to 1 liter. Or 1 liter is equal to 1 kg. 1 kg is equal to 1000 grams. 1000 grams is equal to 1 liter. We know that 1 gram is equal to 1 gram is equal to 1000 mg. So, 1000 grams is equal to 10 to the power of 6 mg. So, 1 liter of water is nothing but 10 to the power of 6 parts. Nothing but 1 liter is equal to million parts. 1 liter is equal to million parts. So, if 1 liter is equal to 1 million parts, if water is having 500 parts of any of these salts, those are called as 500 ppm. Nothing but 500 parts per million. It is the parts of calcium carbonate equivalent hardness per 10 to the power of 6 parts of water. Let us move to the next units are milligrams per liter. The same calculation. It is the number of milligrams of CaCO3 equivalent hardness present per liter of water. It is the number of milligrams of CaCO3 which are present in the per liter of water. In the previous slide, we have seen that the salt water contains 0 to 70 milligrams per liter or 0 to 70 ppm we can call as. So, 1 ppm is nothing but 1 milligram per liter. Million is nothing but 10 to the power of 6 parts. So, 1 ppm is nothing but 1 milligram per liter. Let us move to the next units are degree clerk. It is the number of grains 1 by 7,000 pounds of calcium carbonate equivalent hardness per gallon of water. Per gallon of water. The next units are degree French. It is the parts of CaCO3 equivalent hardness per 10 to the power of 5 parts of water. Degree French is nothing but number of parts of CaCO3 equivalent hardness per 10 to the power of 5 parts of water. If you notice here, in each and everywhere, you have seen the calcium carbonate equivalent. So, whatever the salts present in the water, they were converted into in terms of calcium carbonate. Because it is easy for the calculation, everything we have converted in terms of CaCO3. So, let us see the relation between their various units of hardness. We know that 1 ppm is equal to 1 milligram per liter, which is equal to 0.1 degree French, which is equal to 0.07 degree Clark. We know that 1 gallon is equal to 3.785 liters. 1 pound is equal to 0.453 kg. So, in terms of everything is conversion, you will get 1 ppm, 1 milligram per liter is equal to 0.1 degree French and 0.07 degree Clark. These are the helpful for the calculation within the problems. Let us move to the next topic, types of hardness. Types of hardness. Hardness is mainly of two types. One is temporary hardness and other is the permanent hardness. What is meant by temporary hardness? The name itself it says the temporary hardness which can be removed easily. How it can be removed? By boiling. It is caused mainly due to the presence of dissolved bicarbonates of calcium and magnesium and other heavy metals. So, temporary hardness is because of calcium bicarbonate and magnesium bicarbonates and other heavy metals. Most probably, maximum Temporary hardness causing salts are bicarbonates of calcium and magnesium which are present in the soil. These are the main reason for the temporary hardness. How it can be removed? These temporary hardness can be removed by boiling. Temporary hardness can be removed by boiling. If you boil the water which is having the calcium bicarbonate and the magnesium bicarbonate, the water which is having calcium bicarbonate and magnesium bicarbonate, if you boil here, it gets converted into calcium carbonate, which is insoluble PPT. Calcium bicarbonate, which is soluble in water. If you boil the water, all the calcium bicarbonate is converted into calcium carbonate, which is insoluble PPT, gets settled down at the bottom. Which gets settled down at the bottom. The down arrow indicates that it settled down in the bottom, and which the byproducts are H2O, CO2, water and carbon dioxide. If water consists of magnesium bicarbonate, if you boil that water, magnesium hydroxide and carbon dioxide are the products. Magnesium, this is a calcium bicarbonate, the name of this compound, just it is moved aside, and magnesium bicarbonate. If you boil the both calcium bicarbonate and magnesium bicarbonate, the precipitates are formed as calcium carbonate and magnesium hydroxide, which are the PPTs formed, can be removed by filtration. So, if the water consists of temporary hardness of calcium bicarbonate and magnesium bicarbonate, if you boil it, they are converted into insoluble salts, insoluble PPTs. So, after that you can filter and you can use that water for drinking. Let us move to the permanent hardness. Permanent hardness is due to the presence of dissolved salts of chlorides and sulfates. In the previous slide, see, temporary hardness can be removed by boiling, but permanent hardness cannot be removed by boiling. Permanent hardness cannot be removed by boiling. It is due to the presence of dissolved chlorides and sulfates of calcium and magnesium and iron and other metals. Let us see the salts. What are the salts are responsible for the permanent hardness? Calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate, iron sulfate and aluminum sulfates. All these are the salts are responsible for the hardness which cannot be removed by boiling or simple filtration methods. They require methods which can be tedious methods. There are the chemical methods, some ion exchange methods which are required for the removal of permanent hardness causing salts. Permanent hardness cannot be removed by boiling, but it can be removed by some chemical agents. How to remove the permanent hardness of water? We use certain chemical methods to remove the permanent hardness of water, which are the treating water with washing soda, Kalgan methods, internal treatment methods, Kalgan method, colloidal method, phosphate methods. There are the methods which by adding the chemicals we can remove the permanent hardness because of chlorides and sulfates of calcium and magnesium and other metals. You can also use the ion exchange method. Most probably in chemical industries the people will use the ion exchange method, and the second method is synthetic resin method. These are the methods which we are using for the removal of permanent hardness causing salts from the water. In overall, in today's lecture, we have learnt about what are the sources of water. Rainwater, surface water, underground water, everything we have learned. And what are the various salts present in the water. And second topic we have learned is impurities present in the water. There are the various impurities, physical impurities like color, taste, And chemical impurities like inorganic chemicals, organic chemicals, biological impurities, colloidal impurities, which are responsible for the hardness of water. We have learned what is meant by hardness. It is a characteristic property of water because of all the salts which are present in the water. And types of hardness, temporary hardness and permanent hardness. Types of hardness, temporary hardness and permanent hardness. Again, types of hardness is two types. Temporary and permanent. And types of water, hard water and soft water you have learned, hard water and soft water. And units of hardness like ppm, milligrams per liter, degree Clerk, degree French. In next class, we will learn about the how to calculate the hardness present in the water. Thank you.